In this lab, management wants us to configure a Cisco ASA Firewall. Specifically, management wants us to prevent the outside network from accessing the DMZ or inside network, as well as block the DMZ from accessing the inside network, which we'll first accomplish with interface security levels. Then, management wants us to make sure Facebook.com is available to both the DMZ and internal network. And management wants us to make sure that testweb.com is available to both the outside network and the internal network, which we'll accomplish with permit ACLs. But before we start, what exactly is a Cisco ASA firewall? Firewall is like a shield that protects your network from attacks and unauthorized access. The Cisco Adaptive Security Appliance, or Cisco ASA, firewall blocks bad traffic and enforces security rules, so this keeps your network safe. Why use a Cisco ASA firewall? The Cisco ASA firewall inspects all traffic going in and out of your network. It filters out dangerous stuff like viruses, hackers, and other threats. The ASA firewall also makes sure only approved devices and users can access your network, so this prevents unauthorized access. How does it filter traffic? The two main ways are through ACLs and security levels on interfaces. So before we start applying ACLs or security levels, let's look at what zones we actually have. We have a trusted zone, which is typically your internal network, as it's the most trusted zone. Therefore, it's common to assign the highest security level to the inside interface, which is security level 100. Next, we have a DMZ. The DMZ, or demilitarized zone, is a less trusted zone than your internal network, but still more trusted than your external network. It's like a buffer between your private network and the public internet. It's where you typically place servers that must be accessible from the external network. That's why it's common to assign an intermediate security level to the DMZ interface, such as security level 50. Lastly, we have an untrusted zone. This zone represents your connection to the external network or internet, which is the least trusted zone. That's why it's common to assign the lowest security level to the outside interface, which is security level 0. So let's first console into the Cisco firewall with PC1. Let's name our firewall ASA Firewall with the hostname ASA Firewall command. Something to note is that the commands are slightly different with the Cisco ASA Firewall, which is why I always say it doesn't matter if you memorize all the commands. You'll have to look it up anyways as you run into new operating systems. What's important is you understand the concepts such as looking at interfaces, determining IP addresses, figuring out ACLs, etc. So let's start configuring our interfaces and security levels by first determining which interface belongs to which zone with the show int IP brief command. So even though this command is written slightly different than how we've been doing it in the past, its output is the same as the usual show IP int brief command. We can see that G11 is connected to the inside trusted zone, as it's in the same network as the one in the trusted zone R1 router interface. Then we can see that G1/2 is in the DMZ, as the IP on that interface is in the same network as the IPs in the DMZ zone. Lastly, we have G1/3, which we can see is in the same network as the outside untrusted zone. So, starting with interface G1/1, let's name the interface inside to let us know this is the inside interface with the nameif inside command. Notice we're told that the default interface security level is 100, the highest trust level. Now let's do interface G1/2, which we know is the DMZ interface. So let's name the interface DMZ with the nameif DMZ command. The firewall tells us that the default was set to 0, which is the least trusted area. But we know the DMZ is halfway between the trusted and untrusted zones, so we'll give it security level 50. Finally, let's go into interface G1/3. We know that this interface is in the outside untrusted zone, so let's name it outside. As this is the untrusted zone, let's put in the security level 0 command. These security levels will work with the ACLs we're going to create to control traffic flow through the ASA. Traffic is allowed to flow freely from a higher security level to a lower one. But traffic from a lower security level to a higher one requires an explicit permission via an ACL. Before we get into creating ACLs, let's learn about the object groups in ACLs. Even though it may not be a simulated feature in Packet Tracer, we should learn how we can group these servers together into a group object. We're going to make a DNS server object called DNS-server using the object network DNS-server command. Then we'll assign the DNS server IP to the object, so the ACL will know what server we're referencing with the DNS-server object. Now let's create an HTTP-server object also and assign the web server IP to it. Now that we have our two object groups, if we were on a real Cisco ASA firewall, we could group them into one DMZ-servers group using the following commands: object-group network DMZ-servers, network-object, object, DNS-server, network-object, object, HTTP-server. As we can't group them in this simulator, we'll just create two separate ACL entries for each object. On the ASA firewall, it's slightly different than in the switches or routers. On the ASA, we assign the access list to the interface from global configuration mode instead of through the interface configuration mode. So what ACLs do we actually need? First, let's redefine the goals. Goal 1. Facebook.com should be available to both the DMZ and internal network. Goal 2. Testweb.com should be available to both the outside network and internal network. Let's now list the problems starting from the most restricted zone to the less restricted zone. I like to put it in a chart to make it easy. So, problem 1, with the goals, as they relate to the outside network, which hosts Facebook.com, is that the outside network currently can't connect to the DMZ or internal network. So even if the inside network or DMZ network sent the Facebook web server an HTTP request, they wouldn't get back an HTTP response because it'd get blocked due to the fact that security level 0 can't reach security level 100 or 50. Okay, so what's the solution there? An ACL entry or access control entry, ACE, that will permit anyone from the outside network to send HTTP responses to anyone else. An HTTP response will have the source port of 80, which we know we can use www as a keyword for. Let's name the ACL that will contain the entry as outside to inside. So outside-to-inside. And we're going to write the ACL entries in our work documentation file first, so that way we can copy and paste the whole group of ACLs together into the firewall when we're done. So access-list outside-to-inside extended permit TCP any equals www any. So what we're saying here is an extended access list that permits a TCP protocol from anyone as long as it has a source port of 80 and it can go to any destination. Okay, what's the next problem? Problem 2 is that the outside network won't be able to access the testweb.com web server in the DMZ. Why? Because, as we mentioned before, security level 0 can't access security level 50. And we need to be able to send a DNS request to the DNS server so that way we can translate the testweb.com URL to the web server's IP address. How can we solve that problem? Another ACL entry, this time allowing anyone from the outside network to send a DNS request to the DNS server. A DNS request will normally have a destination port of 53, which we know we can use domain as a keyword for. We also know that we can use the object DNS-server instead of the IP address of the DNS server. Additionally, we know that DNS can use both the UDP and TCP protocol, so we'll need 2 ACL entries. Let's keep the entry in the same ACL we created and start with the first entry. Access-list outside-to-inside extended permit TCP any object DNS-server equal to domain. So we're saying it's an extended access list that permits a TCP protocol from anyone to the DNS-server as the destination, as long as the data packet has a destination port of 53. Pause here and try to create the UDP DNS request ACL entry. The UDP version is access-list outside-to-inside extended permit UDP any object DNS-server equal domain. Okay, cool. On to the next problem. Now that our outside network can resolve the URL, we still need to make sure it can send an HTTP request to the testweb.com web server. So let's create another ACL entry, this time allowing the outside network to send HTTP requests to the testweb.com web server. Pause here and try it first. The ACL would be access-list outside-to-inside extended permit TCP any object HTTP-server equal www. So we're saying it's an extended access list that permits a TCP protocol from anyone to the HTTP-server object as the destination, as long as the data packet has a destination port of 80. Nice. Okay, those ACLs would solve our outside network problems. But where would we put that ACL group? We have 3 interfaces, each with an inbound or outbound option. That means we have 6 choices. But let's narrow it down to an interface first. This ACL group affects all 3 networks, but which problems are we using these ACLs to solve? The outside interface problems. So let's put it on the outside interface. Now, should it be inbound or outbound? Heading in towards the firewall or leaving the firewall? Since this is the least trusted network, we should make sure we only allow what we want going into the firewall. Okay, so we've decided. It will be inbound on the outside interface. What is that command? Access-group outside-to-inside in interface outside. The in here represents inbound. Now let's combine those ACL commands we wrote in our work documentation file and copy and paste them into the Cisco ASA. Awesome. Now let's try connecting to testweb.com from the Facebook web server. It may take a bit for the page to load, so be patient. Great. Now try connecting to the Facebook web server from PC2 in the inside network. Okay, so these issues are officially fixed. Now let's move on to the next most restricted segment, which is the DMZ. So what problems do we face on this one? The DMZ is able to reach the outside network since security level 50 is allowed to connect to security level 0, so that's not the problem. But what about the inside network? Security level 50 is not allowed to connect to security level 100. So what does that mean? That means DNS responses and HTTP responses from the DMZ won't reach the inside network. Which also means that the inside network won't be able to resolve the URLs for Facebook.com or testweb.com with the DNS responses. It also means that the inside network won't be able to pull up the testweb.com webpage with the HTTP responses. So how do we solve those problems? Let's tackle the DNS one first. We'll need an ACL to allow the DNS server to send back DNS responses. Let's call the ACL DMZ-2-inside. The source should be the DNS server, as long as it's sending a DNS response, and the destination should be anyone. Pause here and try to create it. Okay, if you recall, there's actually two ACLs we need for DNS. One of them is for TCP, which is access-list DMZ-2-inside extended permit TCP object DNS-server equal domain any. And the other is for UDP, access-list DMZ-2-inside extended permit UDP object DNS-server equal domain any. Now let's tackle the web server. This ACL needs to allow the source web server to send source HTTP responses to anyone. Pause here and try to create it. The answer is access-list DMZ-2-inside extended permit TCP object HTTP-server equal www any. Now we arrive back to the question of where should we place this ACL group? We have two options to choose from, since the ACL group only really deals with the DMZ and inside networks. Well, who is the ACL really benefiting? Who are we protecting? We created it to allow the inside network to access testweb.com, and we want the inside network to be the most protected. So let's choose the inside interface. But in which direction? We want it closer to the inside network we're protecting, so we'll choose outbound. Pause here and try to create the command to place the ACL group on the outbound inside interface. The command is access-group dmz-2-inside out interface inside, with the out here representing outbound. Now, let's put all our commands for the DMZ to inside ACL together, grab it from the work documentation file, and paste it into the Cisco ASA. Then let's try to connect to testweb.com from the PC. Awesome. That means we accomplished what management wanted us to do. We set up the security levels to protect the inside and DMZ networks. And we created ACLs to permit specific access to the DMZ and public internet. Great job! Now save your Cisco ASA firewall configuration using the write memory command. Then save your Packet Tracer lab and update your notes. After that, write your narrative. Then make sure to share the Google Drive folder where you placed the work documentation file for this lab. Make sure it has the anyone with a link and organize, add, and edit access. Finally, submit the lab for review. If you don't know how to submit the lab, refer to the instructions in the lab's intro video section of this program. After that, you can move on to the next lab.